An investor wants to accumulate 150,000 to purchase a business in 10 years. The investor deposits 14,000 into an account at the beginning of each of years 1 through 5. The investor deposits an additional X at the beginning of years 4 and 5 to meet this goal. The account earns annual effective 8%, calculate X. So the 150,000 is to be accumulated in 10 years, and the deposits form an annuity due the first 5 deposits, the 14,000 ones, and then we have an additional X at the beginning of years 4 and 5. Now, one way to do this is to accumulate or to collect everything at time 0. So therefore, you can find the present value of this 150,000 and then the present value of all the deposits, and they should equal. So we take that approach, and the present value of 150,000 will be the present value of the 14,000 part of the annuity plus the present value of the 2 additional deposits. So now present value of the 150,000, and remember 150,000 is to be collected in 10 years, so its present value will be 150,000 times 1 plus I power negative 10, and that's 69,479. And then the present value of the 5-year annuity due, where each payment was 14,000, can be found by the basic annuity due formula 33.3. So payment is 14,000, interest rate is 8%. So we get 60,370. And now we have those additional deposits of X at the beginning of years 4 and 5. So remember, the beginning of year 4 is time 3. We look at the time diagram, and the beginning of year 5 is time 4, because basically year 4 is actually the time period between years 3 and 4. So its beginning is time 3, and similarly the time period 5 is from time 4 to 5. So its beginning is at time 4. So in other words, the beginning of any period of time is one period before that time. So the beginning of year 5 is time 4, and the beginning of year 4 is time 3. So the additional deposits are happening at times 3 and 4. So the present value of these additional deposits will be, they will be pulled back. The first one will be pulled back 3 years, the second one 4 years. So the X times 1.08 to the negative 3 plus X times 1.08 to the negative 4, because each of these additional deposits was X. So this adds up to 1.5289X. And now all pieces of equation 1 are known. So present value was 69,479 of the accumulated value. And then the present value of the annuity due of 14,000 was 60,370. And then the present value of the 2 additional deposits was 1.5289X. And then this equation, when solved for X, gives us 5958. And so the correct answer is C.